Here we are in Chapter 5, Review 1, Exercises 15 through 20. Here we're using Method 5. Now, Method 5 is special cases. Now, to review what special cases are, we have two of them. If you have two perfect squares separated by a subtraction sign, then that factors into A plus B, A minus B. And most people start out square rooting these to get the A and the B to see that they're perfect squares. Having a positive here and a negative here ensures that no middle term will happen. When you multiply these out, all the middle terms will cancel. And then opposite signs will ensure that it is a negative b squared. So if it's a positive b squared, it doesn't factor. The other one is when something is perfectly squared as a binomial and you multiply this out, you get a squared plus 2ab plus b squared. So going backwards, if you can identify a perfect square there, and then that those two numbers doubled AB in the middle, then you can rewrite it as a perfect square. All right, let's use those and see what we can find here. Here we have negative x squared plus 64. Now, we can do this in one of two ways. We can take the negative 1 out and have x squared minus 64. You'll notice it is a difference of x squared and 64, which is 8 squared. So it would look like this, x minus 8, x plus 8. Or it could have been done in just a little bit different way. Switch these two places and it looks like 64 minus x squared. Still a difference of two squares. And you could write 8 minus x and 8 plus x. Either that written in the green or that written in the blue are both correct factorings of number 15. Number 16. Let's see if it's a perfect square. This is a perfect square. That's a perfect square. So we're looking to see if it's x plus 1 altogether squared, and we have to check the middle term. X times 1 doubled. That's what this middle term means. X times 1 and then doubled. And does it work? Yep, we're good. Number 17. Here's a perfect square. Here's a perfect square. So we're looking at a 7x and a 2. And let's double check. 7 times negative 2 is negative 14. Doubled is negative 28. We're done. Number 18. This is two terms with a minus sign in between them. If we look at the square roots of both of those, we have x squared y and a 3z. So we have a plus on one of them and x squared y minus 3z on the other one. When you multiply this out, those first two timesing together will give you x to the fourth y squared. Middle terms will cancel because of the opposite signs, and 3z times 3z will be 9z squared. Excellent. So number 19. This is a difference, but negative 16 isn't a perfect square. If we take out a negative 1, we now have 16x squared plus 4. Notice these two are perfect squares, but this is not a minus sign, so it can't go any further than that. So this guy, you don't have to write that, but this section is prime. So you could take out a negative 1, but in general, it doesn't factor down any further. Number 20. These aren't perfect squares. Oh, it looks like there's a common factor in here. You can pull a 2 out of everything and you're left with 4y squared plus 36y plus 81. Now that's a perfect square and that's a perfect square, so we see if it's 2y plus 9 perfectly squared. Let's check that middle term right there. Important. 2 times 9 is 18. Doubled is 36. So yes, it checks out. That is 2y plus 9 squared. And that 2 just falls down right there.